You spend months generating precise, groundbreaking data. You compile it, submit the paper, and the reviewers reject it with a single vague critique. It lacks flow. We often treat flow as an innate artistic talent, something reserved for creative writers. But in technical writing, flow is a predictable mechanical output engineered by two distinct systems working together. The first system is coherence. This is your macro-level organizational logic, and it acts as the blueprint for your argument. Coherence ensures your ideas are structured in a sequence that the human brain can easily predict and follow. The second system is cohesion. These are the micro-level grammatical and lexical connections, physically binding those points into a unified chain. Coherence organizes the high-level ideas, while cohesion provides the linguistic mortar that joins the individual sentences together. Possessing only one of these systems is insufficient for professional reporting or publication. Without both the blueprint and the mortar, even the most accurate scientific data will collapse under its own cognitive weight. To see how this works in practice, we have to shift our focus from the macro blueprint down to the micro-level mechanics, how information physically travels from one period to the next. This relies on a foundational rule of technical information architecture known as the given new contract. The underlying psychology is straightforward. To minimize cognitive friction, you must anchor a reader with familiar data before they can accept a novel concept. Let's look at this sample sentence about heavy metals. Soils represent major sinks for metals like cadmium. Here, cadmium is the new information, the novel data being delivered at the very end of the sentence. Now watch how the next sentence starts. These heavy metals find their way into the soil. This is the given information. We start the new sentence with the familiar, just established data to anchor the reader. The novel payload of the first sentence serves as the familiar anchor for the second, locking the two ideas together. This predictable chain reaction creates the physical sensation of flow for the reader. Executing this state transfer reduces the cognitive effort required to process dense technical literature, preserving the reader's mental bandwidth for the actual data. Let's apply this in a real-world engineering teardown and diagnose a broken paragraph about cadmium contamination. This block of text is our diagnostic case study. Soils represent major sinks for metals like cadmium. Soil does not have an infinite capacity to absorb metal contaminants. When this capacity is exhausted, environmental consequences are incurred. Every individual sentence in this sequence is factually accurate and grammatically correct on its own. But despite the factual accuracy, there is zero given new flow connecting the ideas. The lack of logical sequencing forces the reader to mentally jump gaps, creating massive cognitive friction. We can identify a second structural failure point, an inconsistent use of pronoun references. This leaves the reader guessing about what specific capacity or which consequences are being discussed. Third, there is a complete absence of transition words to guide the underlying logic or the relationship between these individual facts. When an author presents facts without engineered sequencing, they outsource the hard work of comprehension directly to the reader. Disjointed data points, no matter how rigorous or scientifically accurate, will fail as a persuasive argument if the structural joints are missing. Let's run the repair. This is the revised text with mechanical fixes applied. The first specific repair tool we use is pronoun references. Pronouns act as low-friction pointers. They carry a subject across the gap between sentences without requiring clunky repetition. The second tool is recycled words. Repeating exact keywords or utilizing direct synonyms is the most efficient way to maintain a given anchor. Creative writers are often taught to avoid repetition, but technical writers must embrace it to maintain unbroken logic chains. The third specific repair tool is the strategic transition word. Transitions function as explicit logical relationship indicators, signaling contrast, cause and effect, or addition. Avoid the novice habit of transition stuffing. Arbitrarily slapping words like furthermore onto broken sentences will not fix bad architecture. Transitions must be used sparingly, deployed only when a clear pivot in logic is required. Look at the fully assembled paragraph now. The three tools work in concert. By deliberately applying pronouns, utilizing recycled words, and clear transitions, you restore the given new contract. These repairs ensure the reader's focus remains on the information, not on deciphering the connections between sentences. Now we can zoom out from the micro-mechanics of the sentence and return to the macro-architecture of the entire paragraph. These micro-chains of cohesion only function if they are bounded inside a rigid macro-structure. The teal model is the blueprint for academic paragraphs. T, the topic sentence, asserts the main point. The E's, evidence and explanation, are the payload bay where given new chains deliver data. L, the link, summarizes the data and bridges to the next unit. Ultimately, true flow is achieved only when these delicate given new chains operate seamlessly inside this strict, mechanical teal framework. Professional writing does not rely on complex vocabulary or artistic flair. Plan the structure, interlock the data nodes, and engineer the text for maximum clarity and undeniable impact.